Today, we're talking about a tool that is an absolute legend in the world of cybersecurity. You've probably seen it in movies, but trust me, the real thing is even more powerful. I mean, just imagine for a second. What if you could knock on every single digital door in an entire network? See who's home, check if they left any windows open, and do it all in just a few seconds. It sounds like something out of a spy movie, right? But it's real. Of course you do. And how it all works is actually a super cool look into the very basics of how computers talk to each other. And this quote right here just nails it. It captures the pure, raw power of the tool we are talking about today. We are, of course, talking about Nmap. So let's break it down. Nmap stands for Network Mapper. It was created by the brilliant Lyon, who goes by the name Fyodor. At its heart, it's a free, open-source tool that helps you discover everything on a network. It basically draws you a map of the digital world you're looking at. And yeah, its reputation is huge. I mean, when you see Trinity and the Matrix Reloaded fire up a command line and run an Nmap scan, that wasn't some made-up Hollywood tech. That was a shout-out to a real-world tool that is every bit as powerful as it looks on the big screen. Okay, so how does a digital detective even start? Well, the very first step is just to figure out who's around. You gotta see who's on the premises. For a network, that means finding all the devices that are actually online. Now, sure, you could use the old school ping command to check on one computer, but what if you have a network with like 250 different devices? Pinging them one by one would take forever. That's where Nmap just shines. You type in one simple command, a ping scan, and it checks that entire range all at once. And the results? Boom. In this example, Nmap found 15 live devices in less than 3 seconds. That's the difference between knocking on every door individually versus having an instant guest list delivered to you. It's just so efficient. All right, so we've got our list. We know who's home. Now the real detective work begins. What are these devices actually doing? Are they hosting a website? Are they a file server? To find out, we have to start checking for open doors, or what we call open ports in the networking world. So how does it do that? How can Nmap possibly know the difference between a door that's open and ready for business and one that's locked up tight? Well, the secret lies in the polite way that computers agree to start a conversation. It's all about something called the TCP three-way handshake. And seriously, think of it just like a phone call. Your computer sends out a little message, a SYN packet, that basically says, "Hello, you there?" If the port is open, the server on the other end replies with a SYN/ACK, which means, "Yep, I'm here, ready to chat." And then your PC sends one final ACK message saying, "Awesome." And just like that, the connection is made. So by completing this entire handshake, Nmap knows for sure that a port is open. It's super reliable, but there's a catch. Completing that full conversation is like signing your name in a building's visitor log. It's loud, it's obvious, and it leaves a very clear digital footprint that any decent security system is going to notice. Finding an open port is cool, but just knowing port 80 is open doesn't tell you much. Is it a modern web server? An old vulnerable one? To really get useful information, we need to gather more intelligence. It's time to peek inside that open door. And this is where Nmap really starts to feel like a superpower. We can add these little things called flags to our command to ask for more details. The SV flag asks, "Hey, what version of software are you running?" The O flag tries to guess the operating system. And then there's the A flag. That's the "Give me everything" button. The aggressive scan is an absolute beast. It combines OS detection, version detection, it runs a bunch of default scripts to grab even more info, and it even traces the network path to get to the target. It's an incredible way to get a ton of data fast. But, like the name says, it is not subtle at all. Which brings us to the, let's say, the sneakier side of Nmap. Firing off a loud, aggressive scan is totally fine if you're auditing your own network. But if you're in a situation where you don't want to be seen, you need to be a ghost. You need to get your info without setting off a single alarm. So remember that polite three-way handshake? Well, the stealth scan does something really clever. It sends that first "hello" packet, and when the server replies, "Hi, I'm here," confirming the port is open, Nmap just hangs up. It never sends that final confirmation. Because the connection was never fully completed, it's way harder for basic security systems to even know you were there. I just love this quote. It's the perfect way to think about it. You're not breaking in. You're just quickly peeking your head in the window to see what's in the room and then pulling back out before anyone notices. You get the intel without leaving a trace. Okay, so if the scans we've talked about are Nmap's standard features, then the Nmap scripting engine, or NSE, is what takes it from being a great tool to an absolutely legendary one. This is where things get really wild. The NSE is basically a framework that lets users write their own little scripts to automate, well, almost anything you can think of. There are literally hundreds of scripts already out there written by the community that can do everything from advanced discovery to finding very specific vulnerabilities. And check this out. This single command, using the vuln script category, basically turns Nmap into an automated vulnerability scanner. It takes all the services and versions it finds and automatically checks them against a giant database of known security flaws. It's like having a security expert automatically check every door and window for you. So, at the end of the day, Nmap gives you the complete blueprint of a network. All the devices, all the open doors, and all the potential weak spots. And yes, that's an incredibly powerful tool for an attacker, but it's an even more powerful tool for a defender. Being able to see your own network the way an outsider would is the absolute first step to making it secure. So the real question isn't just about what you can find, it's about what you're going to fix.